Oh my God. The Mitloehner lab was able to write a research grant through the California Department of Food and Agriculture, and we were able to be awarded that grant. What this grant is really looking at is if we give a methane reducing feed additive early in life, can we have long-term impacts on these cattle emissions? We started with these calves at a calf ranch so that we could get data from these animals all the way from birth to harvest. We raised them up until about 100 days, and then we brought them here into the bubbles where they will stay for the rest of their collection within the study. I'm very grateful for my team because I had junior specialists, my peers, my graduate student peers, I had postdocs, I had a great army of interns all helping to get this done. Because at the end of the day, it's not just about getting cattle through the chute or getting them into the bubbles. We also have to do all the behind the scenes work, whether that's washing the trailer out after, or even getting these animals fed before they get into the bubbles. That way they come to a nice environment where they're ready to eat, they're ready to drink, and they can relax.
Here you see feeders. We put the feed in here. The animals have individual IDs. They're called RFIDs. These feeders know exactly which calf is feeding at any given time, how much each calf is eating. So we have a really good idea of feed intake. We also measure water intake, and we measure the animals' weights every day. And of course, we measure the animals' methane every day. Everything in real time. What's also unique is that this facility here is similar to an outdoor pen. It has the same space allowance per animal and so on as a commercial facility would, but it is totally enclosed. And so we can actually measure not just individual, let's say, emissions from calves, but we can also measure the emissions of the entire group of animals.
Now we can also use a green feed to get individual enteric emissions by using a bait feed. When the animal enters the machine, the feed will drop because they know the animal's there based on their RFID in their tag. While the animal's eating, measure those enteric emissions that the animal's emitting, which allows us to then get an estimated average of emissions from each animal. We have to go pretty slow with them because they don't exactly work like other cattle. They're beef on dairy animals. They were hand raised, so they're super friendly and they've taken to the equipment quite quickly. We do some adaptations as far as helping them learn the system if they're struggling, but most of them take to it quite quickly. Within 5 minutes of putting them in here, we already had one eating out of the bunks. We have 4 total pens and we have 12 animals per pen. This allows us to evenly distribute cattle among our blocks. So it's really important that we have this many cattle in order to have some statistical relevance here. Within these cattle pen enclosures, obviously they provide shade, but we also have swamp coolers where water's trickling down and we have fans in the front to pull in the cool air through. That way we can keep them cool. When we think about the bolus, we'd be able to give this to calves early in their life and potentially have long-term impacts on their methane emissions for the rest of their life. So it's going to be really important for one, application into these cattle that we don't always get to see year-round or every single day because they're out on rangeland. But two is also understanding the early life in general about these calves, especially these calves that are beef on dairy crosses. And we're thinking in a way of how does what we do early in their life, how is that going to affect them for the rest of their life? Thinking about what can I do when we're rearing them at the calf ranch so that they're successful in the feedlot.
It's going to be a challenge to have these babies here on campus, but we are looking forward to this. Our students are ready, our staff is ready, we are ready.